Okay, so let us start the class first. Do you have any question queries regarding last lecture, particularly on the constraint of the system? First, I'll answer those questions and then we'll go for new topics.
Yes, sir. आपने जो क्वेश्चन दिया था डिग्री ऑफ फ्रीडम निकालने का स्फेयर का और सॉलिड सिलेंडर का,
Hmm.
तो उसमें जो स्फेयर है उसका हम लोग सिलेंड्रिकल कोऑर्डिनेट में या फिर ये कार्टेशियन कोऑर्डिनेट में ही कैसे लिखेंगे? ओमेगा मतलब एंगुलर मोमेंटम उसका कैसे लिखेंगे?
No, but first of all, why you need to go to the different coordinate system? Okay, spherical polar coordinate system, you can go, but is that necessary? See, we use a coordinate system for our simplicity. So, I mean, see, changing coordinate is that you know the relation between Cartesian and spherical polar or cylindrical coordinate. So that is fine. But to find degrees of freedom here, do you really need to go to spherical polar or cylindrical coordinate? See, I have given the constraint. Constraint was v, the velocity of that sphere along the inclined plane is omega cross r. Omega is rate of change of, you can make this angular velocity, and which may be the constant in this case, or I don't know, but let me enter this. So what you have to check. Okay, I'll give you some hint. This is a problem you should do yourself, you think yourself. I'll give you a hint. If you have a definite axis of rolling, then probably you can eliminate your velocities. V means x dot, y dot, z dot kind of thing. So those you can eliminate if you have a fixed axis of rolling. So difference between a sphere rolling and a cylinder rolling on an inclined plane is that cylinder has a fixed axis. Cylinder can roll in his own axis, right? But suppose I put a football in the top of the inclined plane, then football can roll any axis passing through his center. So there is no fixed axis of rolling for a football, but there is a fixed axis for cylinder. So try to think in this way. So whenever you have a fixed axis of rolling, particularly in this case, you can eliminate your velocities, and all three constraints will be holonomic constant for cylinder. But for sphere, you have to do yourself that you can find that two of the velocities can be eliminated by replacing, by changing variables, etc., etc. But there will be one velocity variable, because we don't know the axis of rolling. One velocity you cannot eliminate. So in case of solid sphere, there will be two holonomic constant, one non-holonomic constant. Okay, so this is the answer of this. Further details you have to study. See, I have to teach you how to investigate. In physics, everything you have to do yourself. We are here to help you in learning, help you in the doing those. So this is kind of investigation. This is kind of thing which you, when you find answer to yourself, you will get a excitement. You will get a interest to this subject. Any other question? And try to see Rana Jog book. They have discussion. Any other question?
सर सिलेंडर के केस में तो फिर डी थीटा ओवर डी टी लिख देंगे तो वही हो जाएगा उसका ओमेगा. क्योंकि वहां पे तो सिर्फ वही चेंज होना है, और उसको हम लोग के कैप डायरेक्शन भी ले सकते हैं, अगर के कैप लें अलोंग द एक्सिस ऑफ सिलेंडर, वो ठीक है। लेकिन अगर हम स्फेयर में लिखना चाहते हैं ओमेगा का वैल्यू, तो वो लिखने का क्या तरीका होगा वो समझ नहीं आ रहा है।
Because there is no fixed axis of rolling. That is the main difficulty. If you have a fixed axis of rolling, then I think you can write a similar way
Yes,
as
sir.
in the cylinder. So
Yes,
that
sir.
is because of that difficulties, actually you cannot eliminate. So you have a complicated relation. You have to come that velocity component in some other way, and it will be complicated such that you cannot eliminate. Any other question? Okay, so let me then this is continuous disturbing. See, I repeatedly told Mina, this Mina came just now. So this is already 10 minutes. So you have to enter in the class at 9, exactly on time. 5 minutes late, I'll accept, because somebody may have a slow internet, somebody may not have network, kind of thing. But don't think that this 5 minutes is my time. 5 minutes is not time. You have to enter class at the exact time or before. I'll give you at least 2-3 minutes before my class the link. So you should enter the class that time. 5 minutes is the permissible range of your late. 5 minutes is not that your deadline. Dead time is not 9:05 or 11:05 or 10:05. Okay, people think that, okay, sir said 11:05, so I am just 3 minutes late, I am just 4 minutes late. No. Okay, and this gives me a disturbance. See, I am shouting because and I cannot start teaching because you are late and I am shouting to you. Next time I'll deny you. Then you will move around anywhere in the internet. Internet is can take you anywhere in the world, so you can move around anywhere. Okay, any other question?
Yes,
So
sir.
हाँ.
सर जो दूसरा क्वेश्चन था जिसमें रिजिड बॉडी इज मूविंग ऑन अ प्लेन, और हम लोगों को उसका डिग्री ऑफ फ्रीडम, तो वो सेम वैसे ही सॉल्व कर देंगे ना जैसा कि आपने उसके
आंसर पहले बताओ. So my question was a rigid body constrained to move on a plane.
Yes, sir.
A plane is 2-dimensional. So how many degrees of freedom it will have? A rigid body in freely moving 3-dimensional space will have 6 degrees of freedom that I have explained. Now my
Yes, sir.
question is the rigid body moving on a plane, how many degrees of freedom?
Three.
So answer A, B, C, D options are 5, 4, 3, 2, 1. Okay, 5 option I have given. So this Tripti Singh is saying this 3. Anybody else? Anybody else do not have any answer? So this is ridiculous, right? You must have some answer.
3.
Okay, 3. I have to. I'll ask you explanation. Just I'm listening to your answer. Then I'll any answer in physics must support by your. See how many Utkal Dixit. So should I deny now? Okay, let me this day today I'll allow and then I'll deny. If you have some problem, internet problem, etc., that you have to figure out yourself. 2% says 3. Any other answer? If you have a justification for your answer, then give your answer. Not random. It is not that how many people says 4, 5, 3, 2, 1. That I'm not going.
3. Sir, 3.
Okay, so 3. I don't know 3 or 4, but 3. Anybody else? Okay, nobody else has answered. Those those who don't have answer is actually bad situation than those who have wrong answer. So this always keep in mind. See, in the class, I can see there are 56 students. 4 of them has an answer. So rest 54 doesn't have answer. They are in the worst position. They don't have any answer even. Wrong answer is better than no answer.
Sir,
Huh.
sir, rigid body moving on a plane have a 5 degrees of freedom.
Okay, so one answer is now 5. So let me write with red 5. Anybody has any other answer?
Sir, I also think 3 degrees of freedom.
Saurabh Rai is also 3. Let me write with red, no problem. 3.
Sir, I also think 3.
G79 3. Chandro Moli. Okay. Anybody else? Wrong answer is better than no answer. Participation is more important. See, if I have to compare failure and no participation, failure is better. Huh.
So answer is 3.
Somodip Mukherjee is saying 3. I'll ask each and everybody for justification. Okay, anybody else? Last chance. Last time I am asking. This is 11:15. I will not waste time in Sunday. Okay, tell me. Okay, nobody wants to add. Shruti, Sodhanjali, where are you? Are you there?
Yes, sir. Sir, I
why-
am a bit confused about the reason behind it. I thought, first of all, that it should be 3, but I'm not sure.
Okay, but then now what you are thinking?
Sir, I was feeling it has more.
You have a feeling it's more, but multiple choice question, there is no option like that. So Shruti is thinking it may be 4 or 5. Okay. Sodhanjali, not Shruti, Sodhanjali voice. Okay, so now anybody wants to explain why it is 3? Who has a very confident, please explain. Maybe Tipti started confidently 3. So can you explain why it is 3?
सर इसका रीजनिंग वैसे ही है जैसे आपने लास्ट
में दिया था। हाँ, ये हम एक रिजिड बॉडी ड्रॉ कर लिया। ये रिजिड बॉडी, और मान लीजिए प्लेन में मूव कराने के लिए एक फुटबॉल ले लेते हैं, वो बेटर है। हाँ, फुटबॉल, ये रिजिड बॉडी है।
ये से तो फर्स्ट पार्टिकल जब कोई कंस्ट्रेंट नहीं था तो हमने 3 डिग्रीज ऑफ फ्रीडम लिख दिया था।
ओके।
यहाँ पे एक कंस्ट्रेंट है कि मतलब प्लेन में मूव करना है।
हाँ।
तो हमने यहाँ पे 2 डिग्रीज ऑफ फ्रीडम लिखा फर्स्ट पार्टिकल के लिए।
अच्छा, first particle can move only in 2 dimension, you are saying, and the second particle you are saying 1 and 0. Okay, in that way?
Yes, sir.
So those all who have written this 3, they are saying that first particle will have 2, second particle 1, and this 0. So all those who have said 3 degrees of freedom agree with this explanation, or anybody has any other explanation? If those who
Sir, I have different explanation.
Yeah, Saurabh Rai, I'm just wants to listen you.
Yeah. Sir, if we want to fix a plane in 3 dimension, then we lose 2 degrees of freedom, because plane is a 2-dimensional concept. So there, the moment we fix a plane, we lose 2 degrees of freedom, and one constant comes from.
Why? No, just a plane is a 3 degrees, 2 degrees of freedom. Then yes. Why you said that we lose 2 degrees of freedom? That I didn't understand.
Sir, because we are saying that a rigid body moves in a plane, so we have to specify in what plane. So
suppose XY plane. Suppose Z equal to 0 is the XY plane. So you have a one constant Z equal to 0. Z equal to 0, Z equal to A is the XY plane. Okay, so
yes.
Suppose, so then why you lose 2 degrees of freedom? That I don't understand.
Sir, because then there is only one way we can place our first particle in the plane. So then this particle we make the
No,
base.
no. 1 degrees of freedom for first particle, I don't understand. Why?
Sir,
That particle can be anywhere in the plane, so it will be 2 degrees of freedom.
yes, sir,
According to
that is true, but then we have also fixed the direction of the plane. So there we,
direction of the plane, I don't understand.
sir, the
Here
normal
x1,
direction of the normal of the plane.
normal of the plane is the z direction. I said
Yes, sir,
xy
yes.
plane, so z direction. So what is your argument?
Yes,
I
sir,
am not seeing any sensible statement. Tell me clearly. At least I am not
sir,
understanding what you are saying. I understand what these people, the Tripti and other people said. That I understand. Even though
sir,
whether I have not said whether it is correct or wrong.
sir, I will begin again. So suppose we have a plane,
Hmm.
and then we are saying that our object is moving in that plane only. So in a three-dimensional space, when we fix a plane, we have only we have said what plane we our object moves on. Then we cannot specify the one of the orientation. So after that, we can place on particle our object on that plane. Then the object has to remain on that plane, and the rigid bodies have another constraint that these different particles should have fixed distance between them. So there we lose 3 degrees of freedom, because uh, one of them is the constraint that the plane has definite direction. Another is that we have to constrain our object on that plane, and then there is constraint that all the other particles have to be at fixed distance from that fixed point in the plane. So there we lose 3 degrees of freedom, and in all there are 6 degrees
No,
of freedom.
but particle does not have to keep their distance fixed from that point only. Rigid body definition, any two interparticle distance is fixed.
Yes, sir.
Any two, not from that only particle.
Yes, sir.
Okay, so I don't understand actually your argument, and I don't believe anybody in the class also has understood your argument, including you. Whether you have understood your argument or not, think of it. Now I'll listen to the answer 5. Vaibhav Upadhyay, you said 5. Can you tell me 5? Why it is 5?
Yes, sir.
हाँ.
Sir, as I understand, मतलब सर जो रिजिड बॉडी इन 3 डायमेंशनल स्पेस में सर जो होती है, सर उसका सर जो डिग्रीज ऑफ फ्रीडम होता है सर वो 6 होता है.
हाँ,
तो
okay.
तो सर मैं सर पढ़ रहा था थोड़ा सा उसके बारे में. तो सर मुझे मिला कि सर जो अगर कोई बॉडी उसमें कांस्टेंट अगर मतलब के अगर हम कोई ले रहे हैं, मतलब नंबर ऑफ कांस्टेंट्स, तो सर उसका सर डिग्रीज ऑफ फ्रीडम के मतलब जितना होता है n माइनस के हो जाता है.
ठीक है.
तो सर जैसा सर मुझे जितना समझ में आया है कि मुझे लगा है कि अगर ये किसी प्लेन में मूव कर रहा है, तो उसमें सर मतलब एक सिंगल कांस्टेंट आ गया है, मतलब एक प्लेन में कांस्टेंट हो गया है, सिंगल कांस्टेंट. तो रिजिड बॉडी का 3 डायमेंशनल में अगर 6 डिग्री ऑफ फ्रीडम होता है, तो सर इस प्लेन सिंगल मतलब 2D प्लेन में जिसमें मूव कर रही है रिजिड बॉडी, तो उसका सर 6 - 1 हो जाएगा 5.
Okay. Okay. So this I don't know how much you have understood, but you have an overall argument that okay, there is only one constraint and there are supposed to be 6, so 6 - 1 5. Better, sensible, much more sensible answer. But I taught you something, how to find the degrees of freedom of a rigid body, some method. And both the groups are not using, other group is using, but they are wrongly using. So answer is 5. Answer is 5. Correct answer is 5. But if you okay, in this context I tell you, if you I repeatedly telling you, don't read the book by Satya Prakash. This is a student favorite book. I don't know why. Satyprakash book has written degrees of freedom for a rigid body in a plane is 1. Okay, so you can, all of you can find this is a wrong answer, and there are a lot of misconceptions. So I don't like anybody to study Satyprakash. No, not Satyprakash. This is Upadhyay, J.C. Upadhyay book. J.C. Upadhyay has a book, Classical Mechanics. Don't read it. Okay, so this degrees of freedom is 5. Let me answer the way I answered in yesterday. 6 degrees of freedom for rigid body.
Sir, I feel it should be 2, 2, and then 1.
Your term is gone. When I asked you, then whole class I'll not wait for you. So okay, so let me explain. Suppose I have a football, and a football is constrained to moving on a plane. What does it mean? You have to understand that. When I said that football is not moving on a plane, the football is lifted from the plane, then we'll say no, football is not moving on the plane. So there should be one point of contact with the plane. At least one particle in this sphere should have a contact with this plane. At least one. It can have more particles, but at least one particle in this rigid body should have a contact with the plane all the time. Then we'll say that rigid body is moving on a plane. You agree or not?
Yes, sir.
If no particle is in with contact, then we'll say that football has come out of the plane and it is not moving on a plane, it is moving on the space. Okay, so now let us consider that point as our reference. So that point will have 2 degrees of freedom because this point of contact can move only in the plane. So that first particle, I consider that particle which has the keep the contact with the plane. So it has 2 degrees of freedom. Now let us bring another second particle. Now second particle can have 3 degrees of freedom because second particle can move in space. Because this particle is keeping contact with the plane. So this particle can move in 3-dimensional space, but this particle has one constraint. It has to keep this distance fixed with the first particle. So second particle will have 2 degrees of freedom. Because second particle can move not only in the plane but also in the space, because rigid body moving on a plane means that at least one point of contact. So that is maintaining by the first particle. So first particle, this is second particle. Now I bring third particle. Third particle can have 3 degrees of freedom, but it maintain 2 distance fixed. Distance with first particle, distance with second particle. So this particle will have 1 degrees of freedom, and rest all other particle will have 0 degrees of freedom. So total 5 degrees of freedom. So you should think in this way. The Vaibhav Upadhyay also got correct answer in multiple choice, will get full credit. But when you have no multiple choice, then this argument is important. You have to realize this, because otherwise in some situation it may create problem. Okay, so half of the class has gone. Now I hope no other question. Does anybody has any question regarding this solution? Then you ask. Otherwise, we move on. Okay, so
सर
हाँ
सर जो आपने सेकंड पार्टिकल लिया है तो सर सेकंड पार्टिकल जैसे अगर फुटबॉल मूव कर रहा है तो सर एक डायरेक्शन तो फिक्स होगा ना उसका मूव करने।
हम डायरेक्शन क्यों लेके आएंगे?
डायरेक्शन को कंसीडर नहीं करेंगे।
in terms of direction, but नहीं डायरेक्शन कंसीडर कर लीजिए ना। I have not said anything about which direction football is moving. So you first make it that football is moving in this direction. Football may move any direction in XY plane. So that is why the relevance of direction is not important, because it can move in anywhere, na? In any direction. Yeah. My point is that if there is a point which is keeping contact with the plane, then other particles may not be restricted to that plane. You understand a football, when football is just rolling in your football field, just rolling, So there will be some particle which is in the contact with the ground, but there are many other particles which will be above from the ground, right?
Yes,
So they
sir.
are moving in three-dimensional space. Of course, they have some constant because they have to keep the distance between the first particle with the second particle has to keep the distance with the first particle. So that constant I am counting as 1, and then it will be 2 for second particle. So 2 to 1. So Dhanjali realized much later, but I think she wants to tell this. Okay, so this is the argument. So let us teach a little bit today. Okay, anybody has any other confusion? You keep your confusion. You can write me in WhatsApp your confusion directly or in the group, and then your friend also can add in confusion, can remove the confusion. So this is the way. So put your confusion in the group. Somebody should try to remove your confusion. I will also try to remove your confusion. Somebody may add extra confusion. Yes.
सर वो थर्ड पार्टिकल यदि रोटेट करेगा सर, सर्कुलर मोशन यदि करेगा तो सर वो टेबल के नीचे भी तो जा सकता है सर, मतलब वो 3 डायमेंशनल मोशन।
हाँ, तो वही बता रहे हैं ना, टेबल के नीचे जाएंगे फिर भी उनका फर्स्ट पार्टिकल से डिस्टेंस तो फिक्स्ड होगा, फर्स्ट पार्टिकल से डिस्टेंस फिक्स्ड होगा ना, तो एक कांस्टेंट हो गया 3 डायमेंशन में, तो 2 होगा।
बट सर वो टेबल के नीचे जा रहा है तो
नीचे जा रहा है
वो तो सर 2 डायमेंशनल प्लेन तो नहीं होगा, मतलब सर प्लेन तो सर 2 डायमेंशनल है ना, मतलब
अगर ये हमने अगर बता रहा है कि नीचे जाएंगे, हम तो नहीं बता रहे, आप बता रहे नीचे जाएंगे। अगर फुटबॉल आपको ग्राउंड में, ग्राउंड इज योर प्लेन, if the ground is your xy plane, then football cannot go in the inside the ground, right? But आपने बता रहा है, लेकिन even if it is can go the beyond the, suppose I have a plane in a different shape, I have a complicated plane. Plane can be not only flat plane, right? It can be curved plane also. So it can go down also. Plane means not only the you have the table top, right?
So in that case, the particle cannot move on the 2D plane. It can go to the 3D plane. So
no, your concept is completely wrong. Why plane cannot be a flat? I am saying z equal to constant, then it is a xy plane. I can give another relation which can be some other plane, right? It can be inclined plane. That is also a plane. So with reference to your 0, it can go down also, no problem. Suppose I have a plane like this. This point is 0. Now my football is near the origin. So some point is go beyond the 0 point. But still it has 2 degrees of freedom. Second particle will have 2 degrees of freedom because second particle has to maintain the distance fixed with first particle. Football, a rigid body moving on a plane, that does not mean the body is a plane. Body is 3-dimensional. Rigid body is a 3-dimensional, but it moves on a plane. Moves on a plane meaning is that there will be one point of contact. That way you define that there will be one point of contact. If there is no point of contact, then the rigid body is moving not moving on a plane, it's moving on a space. So at least one point of contact will be there, and that point is this point, which has 2 degrees of freedom because it has the contact point and moving on a plane. So this has 2 degrees of freedom. This point will have 2 degrees of freedom because only one constraint. This point will have 1 degrees because they have 2 constraints, and others will be 0. So try to find my error, mistake in this arguments. Okay, so let me go to the next page. How, or maybe I can go to the next, sure, to remove this page. Okay. So presence of constraint is actually put a restriction in the, it is difficulties. So in classical mechanics, difficulties difficulties are due to the presence of constraints. Two type of difficulties. One is that when there is a constraints, not all coordinates are free. Right? If there is a constant, means it all less degrees of freedom, and then all are not free. Second difficulties is that constraint is due to some force, and we don't know the nature of the force. Nature of the force of constraint are not known a priori before, or let me write not known before. So we don't know when we write the Newton equation, suppose Newton's second law, I need to know all the force, but this nature of this force is not known when I write the. So we have the difficulties in studies. So first difficulty is that not all coordinates are free or independent. So these are the two difficulties when we have constraint present in the system. And if you can recover this, remove these difficulties, then we can very easily study our system. So this first difficulties, it can be removed. This first difficulties, so one, let me write one, can be removed by introducing the concept of generalized coordinate. I'll define now. Generalized coordinate, and second condition is removed by D'Alembert's principle. So there is two important. Hello. Hey. एक मिनट आप लोग गैस आपको पूछ के जाना चाहिए। आप एंट्री कर रहे हैं घर में बिना एंट्री के, आपका गेट देंगे तो गैस इधर कहाँ, तो हमको पूछेंगे तब हम बताएंगे। गैस हम लोग यूज नहीं कर रहे हैं। न्यू वन है, हाँ न्यू में जाइए, इधर वो नेक्स्ट पैरेलल एक रोड होगा, हाँ गेट बंद करते जाइए। Okay, hello, I'm sorry, 2% entered in our house without telling anything, so I had to rush. Okay, so I told you, clearly listen, difficult, if you have no constraint, then motion is free, right? There is motion is free, and then it is very easy to study. You can write laws, Newton laws, solve it and confirm. But if there is a constraint means particle moves on a circle, particle oscillates, particle inside a container, or there are many other constraints are there. So you will all learn particle is moved to on a wire, So this kind of constant, if there is if present, then you have difficulties. There are two type of difficulties. One, when constant is present, then all coordinates are not independent. That we know, because degrees of freedom will be less, and this problem can be removed by introducing the concept of generalized coordinate for holonomic constant. So this you should have for holonomic constants. So this is very important, that holonomic constant and generalized. So if my constant is holonomic, and which is holonomic, which is non-holonomic, we have studied yesterday, last class. So for a non-holonomic constant, situation is still difficult, because I'll come to that. And that situation also the another problem is the nature of the constant force. The force which causing the constant is not known a priori, beforehand. If it is not known beforehand, then we cannot set up our equation. And that problem can be dealt with the D'Alembert's principle, which I'll teach little bit later. First, I'll go along this direction, assuming that our constants are holonomic and we introduce the generalized coordinate. So let me introduce the generalized coordinate. So generalized coordinate are defined as the S independent variables required to describe a system with S degrees of freedom. So I can assign S independent variable. They may not be simple coordinate. Coordinate generally has dimension of length. They can have any dimension. They can see no dimension. So S independent variable, this is in my hand. I am designing, assuming that my S degrees of freedom, you have a system with S degrees of freedom, and whatever constant is there is holonomic. So any S degrees, you can many ways define this S degrees, S independent variables. In many ways you can define. So any S independent variables required to describe a system, describe the dynamics of the system with dynamics of the system. So this system is not a dynamics of a system, of the system with S degrees of freedom are known as generalized coordinate. I'll give you a few examples, it will be clear. For example, I have a pendulum. Suppose I have a pendulum, I have a weightless string, and a point particle with mass m is attached to it, and it has a pendulum motion in the vertical plane. So so you can have, say, suppose it is motion is having in the xy plane, but this is a fixed length L. So there is a constant that this point and this point is always fixed. Whenever it is here, whenever it is here, any time, this length should be fixed. So when it is vertical, then it will be deeper. When it will be like this, so it will raise, this mass will raise, right? But this length will be fixed. So constant is that length will be fixed. So if this is my origin, 0, 0, so constant equation is x square plus y square will be L square, and this point, any point is xy. So this is the distance from 0, 0 to xy point. 0, 0 to xy point distance is x square plus y square, and that should be the L square, distance square. Okay, so that is fixed. But this xy are Cartesian coordinate, but not both are independent. And also you know that this system has only 1 degrees of freedom because motion in the xy plane and there is a constraint. So degrees of freedom is supposed to be 2 and then constant is 1. So 2 minus 1 is 1. But I can describe this problem. Suppose this is an angle. At any time it makes an angle with the vertical is theta t. Excuse me. Okay. So I can introduce an angle theta. So this can be considered as a generalized coordinate. It may happen, suppose I have a system of say 10 degrees of freedom. Okay, 4 particles in 3-dimensional space and there are 2 constants. So 12 minus 2, so 10 degrees of freedom. So I can put qi, I equal to 1 to 10 is my generalized coordinate. I am assuming they are independent. Q1 does not depend on Q2 or Q3, Q4, etc. all. So I have a 10 degrees of freedom. I can assign qi, I equal to 1 to 10, like theta. And that problem, pendulum problem, I have only one q and q1, and that so generalized coordinate means that you generalize, you just put some independent variables and demand that they describe the system. If they describe the dynamics of the system, then you can say that those are generalized coordinate. It will be more clear with more examples when we will consider, but at the time being, you note down that it is independent variables, because when we derive the equation of motion, then we'll see that their independent character will be used. Okay. So generalized coordinate is clear. It may have any dimension. It may have dimension of length. It may have dimension of force. It may have dimension of charge, dimension of capacitance. Whatever it is, it may have. It has no fixed dimension. It may be dimensionless also. Then theta is dimensionless, right? Okay. But those quantities should be independent to each other, should not depend mutually. If they depend, then they are not generalized. Then the dependent equation will be an equation of constraint again. Okay. Okay. So now when we have a holonomic and non-holonomic constraint, I'll tell you that degrees of freedom and generalized coordinate. So if you have a holonomic, let us call it first holonomic. Okay. So if they have holonomic constraint, then say suppose k number of holonomic constant. Okay, and say total degrees of freedom supposed to be n particle in 3 dimensions. So this will be degrees of freedom. Degrees of freedom will be 3n minus k. If k number of independent holonomic constraint, then we have this. And if it is this much degrees of freedom, so that will be the number of generalized coordinate. Now suppose a system, this is example 1. The example 2, suppose a system has k number of holonomic constant and k prime number of non-holonomic constant. Okay, you understand. Now I am taking a more complicated system where you have holonomic as well as non-holonomic constant. For example, the case of a sphere, solid sphere rolling on the inclined plane, 2 holonomic, 1 non-holonomic constant is there. So degrees of freedom, again suppose there are n particle in 3-dimensional space, so total degrees of freedom when they are free, no constant, the 3n minus k prime will be your degrees of freedom. This will be the degrees of freedom. So degrees of freedom is always total degrees of freedom supposed to be when they are free minus number of constant, independent constant, whether they are holonomic or non-holonomic, both counted, both in case of this. But generalized coordinate in this case, so number of generalized coordinate will be 3n minus k. You understand?
Yes, sir.
Just a moment. Yeah, just a moment. There is a little bit of. So what I want to say, these numbers I'll be telling you again. But what I want to say that if your system has non-holonomic constant is not in the form of equation, right? You cannot write a equation with equal sign, so you cannot eliminate your degrees of freedom. Suppose I said my constant is such that x square plus y square is greater than less than 0. Then I cannot eliminate my x or y. If I say that x square plus y square is or let me write s square is a square, then I can eliminate my y as root over of a square minus x square, right? I can eliminate. But if I is a less than sign or greater than sign, then I cannot eliminate like this. So non-holonomic constant you cannot eliminate. So you need your generalized coordinate, you actually cannot eliminate. So just a moment here. Why I am not comfortable? Just let me see in my notes. I have some doubt right now. Okay, this point I'll tell you later. I have to see Goldstein book once. There is a one little point in source of confusion. At least right now I am realizing that I'll tell you. So this point, when you have a holonomic and non-holonomic, this example I'll repeat. So don't take it now. So right now we are dealing with holonomic, but when you have both holonomic and non-holonomic, degrees of freedom is this is fine, but generalized coordinate I had little bit of confusion. That will clear you in next class. I have to see Goldstein book for a moment, but I don't have the book in my house. It is in my office. Okay. So now I'm going to tell you this important 5 minutes I have. So this I'll tell you. This is very important, and derivation I'll do in next class. Hamilton's principle. See, when we go to nowadays, it is even you can see from here. We when we visit some foreign country, for example, in Europe. In most cases, we have to consider the net. When we used to do in our student life, postdoc life, that time there was not much internet facilities like now. In mobile. Mobile also was not there in my initial life. But this, when we want to go from one place to another place, suppose I want to go from, then what we do is search in internet, how to go from here to here. If you do make a search, I don't know, this from India, I have never tried, but you can try also. I think nowadays you'll get everywhere. They will give you 3 options, 3 or 4 or maybe more. I have not tried. Least time route, that means the route by which you will take minimum time. Okay. Second is that least cost. They will give you a direction by which if you go, then it will cost very minimum. Least time, least cost, and one more I used to get. Number of changes, least number of changes, like a direct one stop. You have to go by bus, then go by train, metro, this kind of least number of changes. But anyhow, 2 is enough for us. So least time, least cost. Now somebody who has who does not have enough money, he will prefer least cost method. It may take longer time, or least time, least distance, maybe least distance, minimum distance route, that if you go this direction, that may not be least time, that may not be least cost. So there should be a criteria that by which I'll go from here to here. Now Hamilton's principle is like that. It is principle of least action. What is action, that will come later. So right now you said Hamilton's principle, but it is a principle of least action. What is least, you know, because something has to be minimum, some criteria. Least time. So you want to go from your hostel to department. You can go the shortest path, the least path. Least. You can go shortest time. Suppose shortest path is if you have to some straight line or somewhere. Sometimes it may be the same. Least distance and least time, least cost, they may coincide. All 3 will give the same path. That is also possible. All 3 will be different paths. That is also possible. So, so Hamilton's principle says, suppose I have a system at, say, initial time, say system is here, initial time t initial, and described by qi. Okay, and I equal to 1 to s, because s degrees of freedom. Now this is my later time t final. System is again described by, say, q, capital Q for the today, because I will be otherwise misleading, capital Qi, or maybe let me write t initial j q1, or why I am confusing you. So let me I. So generalized coordinate will be different. So system will go from here to here. As time evolves, we want to know how the system evolves. In whole classical mechanics, our main motivation is that how system evolve from initial time to final time, or at final time, what is the situation of the system. Hamilton's principle says it has two parts. Today I'll make the statement. I may take 2-3 minutes more because you may not have any class just immediately after this. So, so let me give you the statement of Hamilton's principle and then I'll explain. So statement is the system will evolve from this point to this point. So how you'll get, how you know that? So for that, let me give you. So it has two parts. Part A. Let me see the Hamilton's principle statement because it is important. Okay. So first part says every mechanical system, let me write, every mechanical system is characterized by a definite function, of generalized coordinate, generalized velocities. I forgot to tell you what is generalized velocity. I'll just velocities and time. So there will be a definite function. Let us denote that function as L, which is function of qi dot. So if you take a time derivative of generalized coordinate dqi dt, total time derivative, then you write qi dot. This is called generalized velocity. Okay, generalized velocity. So Hamilton's principle first part said, very important thing, every mechanical system, every classical system is characterized by a definite function. This is also important, definite function of generalized coordinate, generalized velocity and time. Okay, known, this is known as Lagrangian of the system. So first part, introduce the concept of Lagrangian. Okay, so first part simply says that every mechanical system will have a Lagrangian, which is function of generalized coordinate, generalized velocity and time. All are independent variable. Qi dot is also considered to be an independent variable. Let me write the point B in the up. In the same page I want to write, keeping in mind that the system will go, so part B system will go from initial point to final point. The motion of the system, let me write, the motion of the system or dynamics of the system will be such that motion or dynamics of the system will be such that, that means in like the traveling, the least path, least cost, least time. So similarly, motion should be such that the action of the system, the action which I wrote, action, what is action? Action is defined as by a integration st initial to t final, this Lagrangian qi dot t dt. So this is the action, will be extimum. Extimum means minimum or maximum. So minimum means least. So this is called Hamilton's principle. So this action is denoted by in notation S. Okay. So these are the two principles. I'll just give you the statement and I'll stop here. In next class, we'll use this. We'll explain this statement, and then from here we'll derive the equation of motion. This from here we can find an equation of motion in terms of Lagrangian. So Hamilton's principle says the action should be least. Like extremum, this is extremum is mathematical. Least in very rare cases it can be maximum also, but don't bother about. Extremum means minimum, maximum both, but it is basically minimum. Okay, so don't put much effort to the understand that when it will be maximum. That don't go. I right now I don't have example also. So this will be minimum, action will be minimum, but I'll prefer to write extremum because the condition used will be extremum condition. So Hamilton principle says, just 2 minutes more, I think, keep your patience. Mathematically, geometrically, you have the system here, this system here. System can go here to here infinitely many ways, right? 2 points can be connected. This is the 1 point and this is another point. So it's the initial time system. What is this point, etc.? I'll explain in next class. So system can go in straight line. System can go in many different paths. For example, from hostel to department, you can go directly. You can go via VT. You can go via Lanka. So you can go in infinitely way because 2 points can be connected. So Hamilton's principle says it among these infinity path, it will choose that path where your S will be extremum. That means from Lanka to Kant, you can go infinitely many ways. You can go via Sigra, you can go via this place DLW, you can even go via Calcutta also. You go to Calcutta and then come back to Kant. So there is infinite ways. So now it's saying that, but people will prefer minimum time or minimum cost. So classical mechanics will prefer minimum of action. That action is mathematical quantities. It is a line integral between initial time to final time of the Lagrangian over dt. Okay. So that now I'll stop here. If you have quick question on this, then I'll answer. Otherwise, think about this Hamilton's principle. We'll be using, we'll explain more, and then so when we prefer to go one place to another place, we generally prefer shortest time if don't have problem with money. If you go have problem with money, somebody may go walking, cannot take any vehicle. So it will take a longer time, but minimum cost. You don't have to pay any money. Okay. So similarly, classical mechanics follow Hamilton's principle, which means that system will go from initial time to final time with minimum action. What is action? Action is this mathematical quantity which will have minimum. We will use this concept to find the equation of motion in terms of Lagrangian. So this will be our job. Now I'll stop here. Quick question if you have, just tell me. Okay, maybe then no question. Think of it. Bring your question next time. But bring your question next time. Otherwise, you'll be in trouble. Okay, I'll stop recording. Bye bye.
Sir. Sir, is there any proof of Hamilton's principles?
Principle never have any proof. Do you have any proof of laws?
No, sir.
Principle are like that. Hamilton was very intelligent person. He gave a principle. Now you have to do experiment to verify whether it is correct or not. That's all. Laws, principle cannot be proved. Okay. Okay. You can experimentally verify. If it is experimentally not true, then we'll reject that. Many people, I also have some principle. You may have some principle. But those, if they are experimentally correct, they will survive. If they are not correct experimentally, they will be rejected. Okay. Okay, bye-bye.